In the last video, we looked at a property of chord segments. When two chords intersect inside a circle, we looked at some problems involving a particular property of these chord segments. This one's kind of like a follow-up similar. I'll link the other video in the description in case you want to look at that. In this case, we're going to deal with secants and tangents. So let's look at this statement here. Because of the symmetry of circles, there is a connection between the lengths of secant parts and or tangents when both objects start from the same point outside the circle. So here we have the case where we have two secants. So when we look at this, the length denoted here by A is called the outer part of this secant. It starts at this point and ends up over here on this side on the circumference. And then B, which is B, this segment right in here, is the inner part of the secant. But the total length of the secant is A plus B. So A plus B is the entire, or the whole segment, they say. And the outer part of that secant is A. In the same way for the second secant that we have here, this part right here, C, it's called the outer part of the second secant, and then C together with D, add that together, and you get the whole secant. That's called the whole segment. Now, what property do we have? Do we want to use it? That's this one right here. A plus B, for looking at the first secant. If I add those two parts together, I get the length of the entire secant. So that's called the whole segment. If I multiply that by A, which is the outer part of the secant, that'll equal to the same sort of thing with the other one. If I take the whole segment, there to be C plus D, and multiply by the outer part of that secant, which would be C. That goes from this point to this point right here. They're always going to be equal. Okay, so that's the first relationship that we want to look at. So let's look at one example of what this is saying. Let's suppose that, let's say A is equal to X and B is equal to 6. That would be the inner part of that secant. So B equal to 6. And then C equals to 8. C is equal to 8. And D would be 12. So say you're given that, and the problem is to find the value of X. I'm just going to say find X. So first of all, using this property of secant, in this case two secants, we set up an equation. So the equation is going to be, look at down here, the whole segment. So look at the first one first. The whole segment would be X together with 6. So X plus 6. And we multiply that by the outer part. Whole segment times the outer part, in this case it's X. And that should always equal to the whole segment for the second secant. Assuming, again, this is under the assumption that both secants start at the same point outside the circle and they intersect the circle at 2 points, forming two parts. So this would be the whole segment for the second secant would be 8 and 12. That's 20. And then the outer part of that secant would be 8, just times 8. And of course, this forms an equation. So now we just multiply this out. So multiplying through by X, distribute here. Be X times X is X squared. X times 6 is 6X. And then 8 times 20 is 160. Now sometimes you do this and you're going to get a linear equation. And you just isolate the variable. Now here we get a quadratic equation. Got X squared there. So in this case, what we want to do is see if this thing will factor. So we try to get the terms all on one side. X squared plus 6X. Bring the 160 over to this side. That's the same thing as adding negative 160 to both sides. And then the right side is 0. And once we have the right side equal to 0, then we're hoping that the equation will factor. If it doesn't, there's always a quadratic formula or method of completing the square. Most of these are going to factor for you. So play around with the factors of negative 160. We want to try to get a 6x for the inner term. So this should be what, x plus 16 and x minus 10. Those are the factors. And you can check it out here. X times x gives me x squared. Minus 10 times 16 is minus 160. And then we do the inner term there, 16x, and the outer terms here, that's minus 10x. Add them up, that's 6x, that checks. So now once I have one side 0, that means that the product here is 0, of course, which means that either the first factor, the second factor, or both are 0. So we simply set each factor equal to 0 and solve for x. So the easy way to do it here is say, okay, x plus 16 gives me 0 when x is what? Well, negative 16 and 16 is 0, so it should be negative 16. Then x minus 10 is 0 when x is 10. Now here we're dealing with dimensions of length. So we can't have a negative side or length of anything. So this one we have to reject. So the answer to this one is x equal to 10. And no units are given. This could be inches, feet, centimeters, whatever, but since no units are given, we simply say x equal to 10 units. And that's your solution to that one. So again, you have the whole segment, you have the outer part of the segment, and using this setup here, you generate the equation and then solve for whatever they ask you for. Now, in the next one, says a tangent has no inner part, which means the outer part and the whole segment are the same. So square the length. So in this case, situation could be something like this. So let's say this first one is a secant. The shorter one here that I have is a tangent. And let's say that this length right here inside the circle, that's the inner part of the secant, and the outside part is 4. And let's say for the tangent, that's 6. So this one states a tangent has no inner part, which means the outer part and the whole segment are the same. So square the length. So the only difference is if you have a secant and a tangent, this right here for the tangent, I'm just going to use t for tangent. This is going to be squared here. Instead of the whole segment times the outer part, since it has no inner part, it's just t times t, or t squared. Notice this is the way it works for when you have actual numbers. For the secant, the whole segment is 5 plus 4, which is 9. And the outer part is 4, so that's 9 times 4. And for the tangent, notice this length outside here is 6. There's no inner part for this one. Again, tangent has no inner part, which means the outer part and the whole segment are the same. So you simply square this side. The tangent is squared, this is squared. 4 times 9 is 36. 6 squared is 36. This is just to show you that that's the way it works. The statement is going to be true when you've got a tangent. Now, if you got a 2 secants, then we just looked at an example of that. So now let's go to this one. So this is going to give you an overview of the different cases. So here we have a tangent. MP is a tangent. This is Z here. And MN is a secant. And MO is a secant. Find the value of Y and Z. So what we'll do, we'll simply look at the first, the 2 secants first. And we're going to work just like the first one that we did. So we look at the first secant, MN. The whole segment is 9 and 3, that's 12. And the outer part is 3, so that's times 3. That's going to equal 2. And then look at the second secant, MO. So the whole segment is 2 and y together. So let's put it together, y plus 2. And that's multiplied by the outer part. For the first one, it was 3. For this one, it's 2. So it's just times 2. And then in this case, we have a linear equation, first degree in y. So 12 times 3 is 36. Multiply 2 by 2 here, 2y. 2 times 2 is 4. Now it's just a matter of solving for y. So we're going to add negative 4 to both sides here to isolate the variable, which would be the 2y. 36 and minus 4 is 32. Over here on the right, the 4 and the negative 4 cancel. I get 2y. I solve for y by dividing both sides by 2. So the 2's here cancel. 32 divided by 2 is 16. So y is equal to 16. That's part of the answer there. Now we have to find z. Now, to find z, when I got the 16 here, I used the 2 secant case. Now I have to use in order to find z, I have to use the tangent. So with the tangent, I use one of the secants. It doesn't matter which one. I'm going to use the secant mn and do this. So for mn, the whole segment is 9 and 3, so that's 12. And the outer part is 3 units. Remember here we're dealing with the dimensions, so it's units. This is going to equal 2. And now we're dealing with a tangent. Okay, so remember the tangent does not have an inner part. So it's just the length squared. It's just the tangent squared because they're the same. The whole segment and the inner part are the same. So this is going to be z times z, or z squared. So this is 36 is equal to z. So again, the tangent doesn't have an inner part. So the whole segment, or the inner part if you want, are the same. So z squared is equal to 36. So that means taking the square root here. And of course, again, we don't take plus or minus because we're dealing with lengths. So the value of the variable has to be positive. So this will be 6. Z is equal to 6. Now notice, once I got the value of y, then I could use either one of these. So I could do the same thing. Okay, let's see, I used the tangent again. So basically, if you're dealing with a tangent, what that property is telling you, whatever that length is, whatever the length is of the tangent, whether it's a variable or just a number, you're going to square it. So in this case, if you want z, square it. All I'm doing is working out the problem again using the other secant just to show that it works no matter which one I use. So now if I use the second one, the inner part is 16, the outer part is 2. So the total length of this is 18. And then I have to multiply that by the outer part, which is 2. So z squared is equal to 18 times 2, which is 36. The square root of 36 is 6. So no matter which one I use, once I have the information needed, in this case, once I got the y, then pick whichever one you want to complete the solution. Thanks for watching. We'll see you next time.